finding the whole matrix and then pick the necessary entry that you want. But this is going to be a little bit time consuming because you'll need to find all the entries and then pick the ones that you are asked to find. While here, it's very simple and straightforward. You just pick the appropriate row and the corresponding column from A and B, and you compare them, and the answer is going to be the required entry. Okay. Questions? Any question? Can you hear me?
Yes, doctor.
Yes, doctor.
Yes,
Can hear
doctor.
you. So far, so good.
Okay. So you have no questions? Okay. Let me then show you a few examples here. Okay. Let me take this example from the book. I'm going to copy it and then solve it together with you. And I think I would stop here for today because I wanted to practice a little bit this multiplication of matrices before we move on to other stuff. Of course, there's a lot more to learn about matrices, but this is something which is really very basic. And you can't proceed without having at least practiced a little bit of matrix multiplication. We need to be able to multiply matrices, and very quickly, in fact, okay, to proceed further. So let me take this example, these two matrices. So do you think we can multiply these two matrices? Look at them, A and B, these two matrices. Do you think it's possible to multiply A times B, let's say?
No.
Yes, because you see A has two columns, right? And B has two rows. So yeah, it's possible. It's even possible to multiply B times A, right? B by A, because B has three columns and A has three rows. Right. Also, we can do it in the reverse order. Not only AB, but also we can do BA. And by the way, so before I proceed even to this, do you think that AB? So here, AB and BA are defined. AB and BA are defined. But do you think are we going to get the same answer? A times B or B times A? Will the matrix be the same?
No.
So I can't hear what you're saying if you are answering this question.
I'm saying إنه ما حيكونوا نفس الجواب.
Yeah, why? Can you tell me why?
أكيد مش نفس الجواب لأنه أصلاً ال A هي 3 by 2 وهديك 2 by 3 والأرقام مختلفين.
Okay. So if I take if I take the matrix A, so in this case, okay, let me. So do you know what? I'm just going to write it here without copying the numbers. I will come back to the numbers later. So this matrix A. So what is the size of the matrix A? The size of the matrix A was 3 by 2, right? And the size of the matrix B was 2 by 3, right? So what do we get if we multiply A by B? If we multiply AB, what will be the size of this matrix?
3 by 3. 3 by
3.
And
right.
BA.
Okay. And what if we multiply B times A?
2 by 2.
Yeah, we get 2 by 2. Now, do you think that there is any hope for these two matrices to be equal? These two. Can they be equal?
No.
They are
No,
not equal.
certainly not. They have different sizes, right? If they have different sizes, you can't even begin to compare them, right? There is no way that you can compare two matrices of different sizes. So certainly AB is not equal to BA, even when the multiplication is defined, right? Now, of course, in some special cases, very special cases, I should say, the results may be the same. But in general, they are not the same. And this is something that you need to remember about matrix multiplication. AB is not equal in general to B times A. Okay, so remember this. Unlike numbers, right? If you multiply in numbers, if you multiply x by y, it's the same as y times x, right? In numbers, right? It's always true. But in matrices, it's not true. It's not generally true. A times B is not the same as B times A, okay? This is something that I will come to later, okay? But I wanted to just mention it today because it's very important, okay? So remember that, as we say usually, multiplication of matrices is not commutative. Remember, commutative, it means you can switch the order without a change. Here we say it's not commutative because the order does matter. The order matters, okay? And now, let me now take the example in the book. Okay, so now I want to find the 3-2 entry in the matrix AB. The lights, I think, went out here. Yes. So just wait for a few minutes, okay, for the lights to come back. Okay. Can you hear me?
Yes, doctor.
Yes. Okay. So I'm waiting for the light to come back.
То, наверное, тоже учится.
Okay, I think the lights are back. Yes. Sorry for that. Okay, can you hear me again?
Yes, doctor.
Good. Okay, so I want to multiply these two matrices A by B, but I want to only find one entry. The entry which is in the third column, in the third row. Sorry, you see this entry 3-2, right? So this is the third row and the second column. And to find this entry, I need to use because I'm doing the multiplication A by B, A times so A first and then B, right? Then I need to take the third row from A, okay, and the second column from B, and just make the pairing, okay? And now you can see that the second row, the third row in A is 2 and 6, right? And the third column in B is 3 and 6. So when you pair, you will get 2 times 3, which is 6, right? Plus 6 times 6, which is 36, and this will give you 42. So this entry here, the entry 3-2 in the resulting matrix, the product AB, is going to be 42. Okay, and now I'm not sure where the book is doing it. So here it's a very long solution, but you see the answer is 42, right? The answer is 42. We take only so I just focus only on the third row in A and the second column in B. Let's say I want you to find, suppose the entry, let's say 2-2, okay, which means the second row and the second column. Okay, so you use now, instead of the third row in A, you use the second row now in A.
9 plus 6.
Yes, 9 plus 6, absolutely, which is 15. So if we have the matrix, we can check it, and you see it is here. It's 15, the 2-2, right, entry. It's the middle entry in here. Okay, And that's it. You can do it. You can do it in the same way for any pair of matrices. I think I would stop here for today. Do you have any questions? Yes.
You said recently that this kind of matrices we cannot switch the equations, right?
We cannot what? Can you say it again, please?
And switch the order of the equations.
The order of the matrices, you mean?
No, you said that before when we were using matrices, we could switch R1 to R3, for example. Switch places.
Yes. No, here you can't. Here you can't. Of course, yes. This matrix. So yeah. So for example, the matrix. So let me just this is a good question. This is a good question here because you see, not every matrix is coming from an equation, from a system of equations. In fact, so for example, the matrix. If I give you the matrix, let's say 2, 1, 0, 1. This is not the same as the matrix 0, 1, 2, 1. Certainly, it's not. It's a different matrix. Yeah, so you can't simply switch the rows.
Not always a system of equations. It might be something else.
Oh, yeah, of course. Matrices, of course, yes. I mean, not only system of equations. Matrices, now, maybe not in this course, but you will see it perhaps later. Matrices, they can be used to do transformations in the plane. You can do geometry using matrices. In fact, any kind of multiplication between two objects, you can always represent it, as we say, using matrices. So matrices are much more general than simply equations or systems of equations. Yes, but we are using them to solve systems of equations, at least in this course.
Thank you.
Okay. But what you said is true. So this matrix, the matrix on the left here, is not the same as the matrix on the right. They are completely different, certainly, right? Okay, then there will be a homework for the next time, as I said, for you to practice multiplication of matrices and matrices by vectors, okay? And I really insist that you try your homework just to get the hang of it, okay, the multiplication. It's easy, but it needs some practice if you are seeing it for the first time, okay? See you then on Tuesday.
Bye, doctor.
Bye, see you.
Doctor, please don't
يعطيك
forget
العافية دكتور.
the link of the Jumbo.
Oh yeah, I will. Yes, I will.